Hello, my name is Taylor Lewis from RTI International, and what I'll be talking about in this presentation is strategies and evaluations involved in combining probability and non-probability data to produce official statistics. And before I begin, I'd like to acknowledge my co-authors, Dan Lau and Marcus Brzozowski of RTI International, and Alexia Cooper of the Bureau of Justice Statistics. I'd like to say a few words to set the stage for the background and the context of the problem that we were trying to solve. And that is that traditionally the FBI has been reporting data through the Uniform Crime Reporting System. It's been in place for about 100 years. And traditionally this data is fed in by law enforcement agencies in a summary form, basically aggregated monthly counts. And the FBI is replacing this system with something called NIBRS, which stands for the National Incident-Based Reporting System. And this provides much more detail on crimes. It's incident-level information. But the issue is that law enforcement agencies need to upgrade their record management systems in order to be certified to submit the data in this form to the FBI. As of 2018, only about 8,000 of the 18,000 LEAs have successfully transitioned into the NIBRS system. And the issue is that reporting agencies are not randomly distributed, and they tend to be skewed towards less populated states. And you can see that on this slide here with the map showing darker states being those that have a higher proportion of LEAs reporting. Some of the big gaps appear in California, Florida, New York, which are some of the very highly populated states. This reporting gap has been known for some time, and back in 2011, through an initiative referred to as the National Crime Statistics Exchange, a probability sample of 400 LEAs was drawn to represent those who were not reporting at that time. And the design of the sample also included a certainty stratum for the largest LEAs, defined as those with 750 or more police officers. And the idea was to use this supplemental sample to represent those that weren't responding at the time and combine them with the LEAs that were responding at the time. Because there are a lot of moving parts to this NIBRS estimation issue, I think it helps to have a visual representation of the various types of LEAs, and that's what I've tried to do here on slide number 5. So the area of the outer rectangle represents the target population, all of the 18,000 LEAs, and the green zone at the top represents what we refer to as early adopters, those LEAs that were already reporting to NIBRS in 2011. So the purpose of the NCSX sample in 2011 was to represent the non-green portion of the rectangle here, and it was done by way of these blue regions, the one on the left being the certainty stratum, selecting all LEAs that had 750 or more police officers, and the oval region represents a stratified random sample of the remaining 9 or 10 strata. And those two regions together combine to 400 LEAs. The complicating factor is that in 2018, not all of the NCSX agencies are reporting to NIBRS. The zeros represent, both within the blue region and outside of it, any LEA that's not yet reporting to NIBRS. The X's represent LEAs that between 2011 and 2018 have become NIBRS reporters. So there are cases inside the representative sample that are have no data and are missing. And then there are also cases in the NCSX eligible universe that since 2011 have started reporting to NIBRS on their own. We refer to those LEAs that were not reporting to NIBRS in 2011 and weren't part of the NCSX sample but began reporting on their own sometime between 2011 and 2018 as new joiners. And so the challenge becomes, how do we develop an optimal method to weight up the cases in the NCSX sample who are reporting to NIBRS alongside those who were already reporting in 2011 and these new joiners. And we want to be able to validate whatever estimation strategy we use to ensure that it's producing representative estimates of crime both at the national level and the state level. In terms of the specific strategies employed, we evaluated two estimation strategies, which I'll talk about on the next two slides, and thereafter we'll talk about three different weighting/blending strategies we used. So the first estimation strategy, we refer to it as the top-down approach, and the idea is to make NIBRS reporters look like the full universe of reporters so that we could start with national crime estimates and evaluate them at that point. Now, one thing we did under this approach is to treat the super large agencies as self-representing. And those actually come from that certainty stratum, which was part of the 400 NCSX sampled agencies. So the remaining 328 agencies, we combine them with new reporters since 2011 and weight them up to represent everyone except for those super large agencies. The second distinct estimation strategy we evaluated, we referred to as the intermediate approach. And unlike the top-down approach, which just attempts to weight the LEAs to the national level, the intermediate approach looks at each state and says, if their coverage looks sufficient, which we used a rule of 80% of crimes being reported into NIBRS. And remember, we know the full denominator from the SRS reporting system, which is already in place. So essentially, the intermediate approach says if the state appears to have sufficient coverage, let's go ahead and make a weighting adjustment for the LEAs in the state who aren't reporting. And for all other states below that threshold, group them together and produce a series of weights very similar to the top-down approach. Now, the idea of this estimation strategy is that over time, we'll be able to achieve a 50-state design, but along the way, instead of waiting until all 50 states are ready to report, we can report those with sufficient coverage, that growing list over time. So those are the two estimation strategies we considered. I next want to spend a few moments talking about three distinct weighting strategies we considered to blend these various types of LEAs. The first weighting strategy we referred to as the naive design-based approach. And the idea here was to use the sample of 400 LEAs, except for perhaps those 72 large ones that we were treating as certainty LEAs, to represent any LEA that was not responding to NIBRS as of 2018. So this excludes from consideration a couple of other types of LEAs, namely the early adopters, those in the green region from the schematic representation seen previously. Those were the LEAs that were already reporting to NIBRS in 2011 and thus ineligible for the NCSX. And then the red circle represents those LEAs that joined after 2011 and before 2018, but were not selected as part of the NCSX sample, even though they were eligible. So the idea is to let those early adopters and new joiners be self-representing with weights of 1, and only the remaining 328 non-certainty LEAs that were part of the original sample of 400 NCSX agencies, allow them to represent not only themselves, but all the remaining non-joiners. So we thought it would be worthwhile to evaluate this strategy because it's the closest one to the original intent and design of NCSX back in 2011. We felt like theoretically it should have the smallest amount of bias, but perhaps larger variances than some of the other strategies we're evaluating. But the clear disadvantage in our minds was that it was unclear whether the original sample design would still be applicable in the world today, now that we have a substantive number of LEAs that have joined into reporting into NIBRS on their own. The second weighting strategy we considered, we referred to it as blending new joiners. And the idea is that instead of having just the NCSX LEAs represent basically any LEA that wasn't already reporting to NIBRS in 2011, to blend those 400 or so LEAs with the new joiners. That means the LEAs that were part of the eligible universe to be sampled, but just weren't sampled, yet between 2011 and 2018 have started reporting to NIBRS on their own. And we would still retain the early adopter stratum as being self-representing with all the weights for LEAs therein equal to 1. Now, the advantage of this approach is that we felt it should smooth out the weights a little bit relative to the design-based method, the naive design-based method. This does deviate a little bit from the original sample design, and so it may introduce some bias, but we thought it was worth evaluating since it seems like the new joiners could come from the same type of pool of agencies as those that were sampled, particularly within the various strata under the NCSX sample design. And finally, weighting strategy 3 we refer to as blending all reporters, which in short just says if you're any kind of reporter, whether you are reporting through the NCSX sample, you are a joiner on your own after 2011, or whether you are reporting at the start of 2011, put all of these in one pot, and we no longer have self-representing portions of the universe. Just let all these LEAs have a weight that is equal to something other than 1 to represent the entire universe of 18,000 LEAs. In terms of the advantage, we would expect this would minimize the variance in the estimates, mainly because there would be less variability in the weights. And we also felt it was most likely to introduce bias into the estimate. So we were a little concerned about this particular strategy on that front, but we thought it was a pertinent strategy to round out the 3 particular weighting strategies we wanted to evaluate. To validate statistics generated from our various estimation and weighting strategies, we created a few template tables, and one is shown on this slide. And the idea was to use the NIBRS reporting weights to inflate values from an external source and compare what the NIBRS weights statistics say relative to the known totals. And remember, these external sources, there was one for crimes and one for arrests. Those were not subject to the same missingness patterns that the NIBRS system is subject to. In terms of results, if we had to pick one potential winner, at least as of the 2018 picture, it would be the intermediate blending new joiners approach. It had the lowest relative bias with respect to crimes and also the lowest RSC on those estimates. With arrests, it didn't necessarily have the lowest relative bias, but it did have the most precise estimates. And you'll notice that on the arrest side, all the relative biases are negative. So there's some systematic underrepresentation of arrests that's happening when we weight up the NIBRS reporting agencies that we're looking into. There's still a little bit of an underestimation going on the crime side, but it's not nearly as pointed as it is on the arrest side. In terms of next steps, the first thing we'd be interested in doing is determining whether these same preliminary conclusions hold with the 2019 data. This will include not only crime counts and arrest counts that have changed, but also a new set of LEAs that have since become NIBRS reporters between 2018 and 2019. We're also exploring a variety of post-stratification methods using this benchmark data for crimes and arrests from the SRS. The challenging factor with that is that it's sunsetting, as I mentioned, as agencies are forced to transition to NIBRS. So how and for how long we can use that information remains a little uncertain. Another thing we're doing is evaluating what happens when we relax the assumption that all LEAs that were part of the NCSX sample are in fact NIBRS reporters. Turns out that not all of them are. There's still a large number of them that are working on transitioning to NIBRS. And so redoing the weights accounting for an adjustment at that level will be needed as well. Thank you for your interest in this presentation. If you have any questions or comments or recommendations, please feel free to send an email to thlewis@rti.org.